Welcome to this third part in this video tutorial series about the OpenGl API. So in the previous part we worked with primitives and we had this output. This is some sort of triangle looking thing. So in this part we're going to work with animation. I planned that I'll work with colors too in this video tutorial, but it turns out I'm just going to do animation in this one. We'll cover colors in one of the upcoming parts. So this is the output which we're going to have at the end of this video tutorial series. So this is what you'll be able to do after you have finished watching this video. This is just simple animation in OpenGl in the double buffering mode. So let's get started with animation. I'll sketch some basic ideas of animation, how it works here. Now I assume that you are already aware of how simple animation in the movies or in the films work. It's like you have an object here in the first frame. So animation is just basically clear and redraw in the successive frames. So in the first frame you have your object here, in the next frame you'll have it here, in the next frame you'll have it here, and then in the next frame you'll have it here, and this just keeps it just continues. So if your frame rate is sufficiently high, that means you are displaying the frames at a faster rate and your distance that you move in each successive frame is sufficiently low, that will result in a smooth frame, a smooth animation. So that is what we're going to do in OpenGl here. We'll be aiming at 60 FPS, 60 frames per second. That means the screen will be refreshed 60 times in 1 second. So you need to draw a new frame every 1/60th of a second. That we'll use this because most of the displays use this frame rate, and it is also sufficiently smooth, so we'll not have no distortion or any other problem. So now let's talk about OpenGl. So in OpenGl, displaying frames is just clear and redraw. We just draw some stuff, we clear it for the next frame, and then we draw the stuff at a different position. So this is the frame buffer. So this is the display function. So one call in OpenGl, one call to the display function in OpenGl will be considered a single frame. So each time we call the display function, we display a single frame. So to make it look like animation, you need to call the display function again and again periodically, and alter the primitive that you are showing. Also, you need to alter it periodically. So we'll just work with the geometry later on, but let's see the display function for now. So first, at the beginning we clear the whole of the frame buffer. So we talked about the frame buffer in the previous part. It is just the area and the memory which stores the pixel that are going to be displayed on the screen. So we just clear the frame buffer. That means we just clear the screen. You can use the names interchangeably here while understanding animation. So we just clear the screen, we initialize it, we draw a new primitive, and then we like flush it. This is actually when it is being displayed on the screen, but before that we just editing the frame buffer. So we just clean and we draw, and for the next frame we clean it again and we draw at a different position. So that is just how simple animation in OpenGl works. So let's have a look here. So let's suppose this is a screen and we're drawing this primitive here, and we're drawing this for each successive frame. And the problem here that might arise is that if your geometry is too complicated to be displayed fully in one frame, like OpenGl is not able to fully render it in one refresh cycle, so only the half of the object will be displayed. Like your time has reached for the new frame to be displayed, and your frame is not being completed yet. So the incompleted frame, which is not been rendered completely, will be displayed on the screen, and that might continue for a longer period, which might result in distortion of your images, which is not quite desirable. So this might occur in the machines which have low performance. So to solve this problem, you need to switch to double buffer display mode. You need to switch to double buffering. So that eliminates this problem. And now let's see how to do that. So now in the main function, we called have a call to the init display mode function. We initialize the display mode to be RGB. We also want it to be double buffered, so we'll call it glut double. So this is just, we just combine these two display modes using the OR operator. So this means that we also want RGB mode and we also want a double buffer display mode. So we are requesting a double buffer display mode while initializing this. So we now have a double buffer display mode, and let's see what that means. So in the double buffer display mode, you actually have two frame buffers. So let's suppose these are our two frame buffers. This is the first one and this is the second one. And one of these frame buffers is actually called the front buffer, Let's suppose this is the front buffer and the other one is the back buffer. So what's the difference is that the front buffer is the one which is currently being displayed. So like this is the buffer which is on the screen right now. This is the geometry which is on the screen, which you see on the screen right now. And the back buffer is the one which you use to draw. It is not being displayed on the screen. It's just in the memory. So the one which is being displayed will not be used to draw, but you will draw onto a different frame buffer. You will draw an object at a slightly different position, like you draw it in the middle in this one, at a slightly different position in this back buffer. And when you finish the drawing, you can swap these buffers. That means the front buffer will become the back buffer and the back buffer will become the front buffer. So it'll become the front buffer now and it'll become the back buffer. So it'll be displayed now. This buffer is being displayed now. You can just see that your screen changed the display. It was first displaying this and now it is displaying this. So that is just the next frame. So now for the next frame, you need to, now the next frame, all the operations that you carry out to draw stuff will be carried out on the back buffer. So now we'll draw onto the back buffer, we'll clear it and we'll draw it at a slightly different position, and now we'll swap the buffers again. So animation in the double buffering mode is just redraw and then swap. We just redraw our scene on the back buffer and then we swap the buffer. That means the back buffer will become the front buffer. And now we change the other buffer. So you can see here, now in the display function, the one thing you need to change is instead of GL flush, you need to call glut swap buffers. Means this, all the operations that you were carrying out were being carried out on the back buffer. The buffer which was currently on the screen was not being changed. And now once you finish your drawing operations, you can now change the back and the front buffers. After this call, this geometry will be displayed because the front buffer will become the back buffer and the back buffer will become the front buffer. So now this geometry will be shown. And for the next call to the display function, this geometry, the next geometry which the display function draws will be drawn onto the back buffer again, and at the end of that the buffers will be swapped again. So that's just redraw and swap again and again to display smooth animation. So this eliminates the problem of your distorted images, because in case your scene is, this is let's suppose this is the front buffer for now and you're drawing on the back buffer, and that you have reached the time in which time you need to swap the buffers, means you need to display the next frame. So you need to display this frame in that time period. Your time has reached, but you have not finished drawing your scene yet. So what you can do is, for the next frame you can keep displaying this buffer and you can finish your drawing, and when you finish the drawing then you can swap the buffers. So that means this will result in a slightly slower display rate, but it'll remove the distortion problem. The image, the animation will be slow, but there'll be no distortion problem. So that is how it eliminates that problem which was caused by single buffering mode. So that's why in animation in OpenGl you always use the double buffered mode. So we have the glut swap buffers call at the end of this function, and now we have a working double buffer display. Now we have the output that we're going to, I just showed you an application which showed you the output that we're going to get at the end of this video tutorial. So let's start working on that now. So first we need to have a look at the coordinate system. So this is the coordinate system that we set using the orthographic projection in the previous part. So the negative x-axis is this side and the positive, so positive is this side, and we go from -10 to all the way up to +10. So that is what we're going to use in the animation that I just showed you. So let's suppose this is a screen and this is the x-axis. So we need to draw a cube at this point. Initially it is at this point, and we're going to draw it about this point. So this will be -10 on the x-axis. Let's just not worry about y-axis here. So this cube will be drawn for the next frame. It will be drawn at this position. For the next frame it will be drawn at this position. So this position will go from -10 to all the way up to +8. So now I cannot take it up to +10, because if I take it this position, this side of the cube up to +10, then it will be drawn out of the screen. We do not want this. Since this we'll keep the side of this cube up to 2 units, so +8 will be this and this will be 10. So -10 to all the way up to +8. this square has the side of 2 units. So this is what we're going to do. So the minimum x position is -10 and the maximum it goes all the way up to +8. First let's implement the geometry and let just change this thing. So vertex 2f. Now this position, the position on the x-axis is variable, so it goes to from -10 to +8, but on the y-axis it is just constant, it does not change. So I need to define a variable here which stores the x position, because I need to update it. I need to update this variable for each frame so that the x position is changed for each frame. So initially it is -10. We'll assume it is -10 initially. So now we'll draw the cube at this position. X position, and the y will be 1.0. And I told in the previous part, always remember the order should be anti-clockwise. Now I have the geometry here of the cube. Now if you do not understand what this is, it's just the geometry of the cube, which has a side of 2 units, which the top left corner of this cube is at this x position. So if you do not understand this, you can just take a graph paper and take any value of the x position and plot these points. You'll get a square, which has a top left corner at this point. So this is as simple as that. Now we have a cube, and I can build and run to show you that if this geometry is correct or not. We have a cube at the desirable position, and now we need to switch. We need to change its x position periodically for each frame. Now the problem here is that the display function is only being called once at the start of the application. We need to call it again and again within a certain period of time. So to call this periodically, I need to introduce you to another callback in the OpenGL in the glut library. So this is glut timer function. So what this function does is that it calls a certain function after a specified amount of time. So let's suppose so the first argument is the time after which you need to call the function. It is in milliseconds, so 1000 milliseconds equal to 1 second. So if you need to call the function after 1 second, you need to pass this as an argument. And now the second argument is what function you need to call. So that is a pointer to the function. So the function should be of type return type void and should take an integer argument. So we need to first define that function here. We'll just call it timer, and the argument type should be integer, and we'll go down here, we'll define it. Now you can define a variable here, but we're not going to use this, so I'll just prefer not to make any new variables right here. So this is our function, the definition and the declaration up here, and here I can register this. So this timer function will be called after 1 second to call to this function. So after this function call, 1 second after this function call, this timer function will be called. And the third argument to this function is an integer which is passed into the function, this integer argument here. So we're not going to accept any values, so you can just keep it 0. Although you need to pass an argument, it is necessary. So just keep it 0 and will not accept anything here. We're not going to use this feature of this callback. So just keep it 0 for initial time, initially. Now this only works for one time, so that you register this function, and after this amount of milliseconds this function is called, and that's all. OpenGL is done here, but we need to keep calling this on periodically. So what we'll do is we'll register the timer function again here, and now here we'll take care of the time period. So we wanted 60 fps, means 60 frames per second, means every 1/60th of a second a new frame should be displayed. So our periodic function needs to be called every 1/60th of a second. So 1000 milliseconds equal to 1 second, and every 1/60th of a second we need to call this call the periodic function. That means 1000 milliseconds divided by 60 milliseconds. So after this much milliseconds we need to call this again, and we'll just pass the argument again. Timer means this function is going to call itself. After this call, this timer function will be called again, and third argument we'll just keep it 0 again. So this will create a loop. Now this timer function will call itself periodically after this much time. So in 1 second this timer function will call itself 60 times. So we have our periodic function here. Now we need to do this for the display function. We need to call this in this period of time. So for that you'll use glut post redisplay. So what this function does is that it posts the urge for the redisplay to OpenGl. That means after an encounter to this function call, OpenGl will call the display function the next time it gets the chance. So after glut post redisplay has been called, OpenGl will call the display function by itself. That means if this function, the timer function, is being called 60 times in 1 second, that means the redisplay function will be called 60 times in 1 second. That means the display function will be called 60 times in 1 second. So we have our desired frame rate. Display function is being called at the rate that we want. Now let's go over this mechanism once again. So at the starting of a program, first this timer function is called. So after 0 milliseconds, it calls this function, and now this function keeps on calling itself every 1/60th of a second, and also calling the glut post redisplay. That means the display function also keeps on being called 60 times in 1 second, and we have a new frame being displayed 60 times in 1 second. But the difference is here is that every frame has same content, the same geometry, so nothing will look like animation for now. So if we need animation, we need to change the geometry. So if we change the X position little by little for each frame, it will appear as animation. So you can update the X position either in the display callback or in the timer function, but I like to do all my update stuff in the timer function. So X position, the global variable that we just declared here, that we're using to draw the cube, will update it plus equal to, will update it at a sufficiently small value. So just 0.15, this is going to be enough. And now we need to keep updating this until it has reached a value of maximum value of plus 8. So it is initially -10, so it goes all the way up to plus 8. If X position is greater than less than 8, then it will keep on updating it. If it is exceeded 8, then it will not update it anymore. So let's just see if this is working. There we go, we have a basic animation here. It goes all the way up to this side and then it stops. And now if you want to make it go back and forth, you can implement a very simple logic here. You can declare an integer variable state to tell you that if it has to go right side or left side. So I'll just call it state, and if this variable is 1, positive 1, then it means it is going to right, and if it is -1, that means it is going to left. So now I'll just use a switch in case of if, and we'll switch the state variable, and we'll case if it is positive 1, that means it is going to the right side. That means we need to increase the X position if it is less than 8. So if X position is less than 8, X position plus equal to 0.15. And if it has exceeded 8, that means it now needs to go to the left side. That means state will become -1. And now we'll break out of this. And now the second case, -1. If the state is negative, so that means we're going to the left side. So X position, so minimum X position is -10. So if it is greater than -10, that means it still needs to come more to the right side. So X position will keep on decreasing now by the same amount. Remember, you need to keep this amount small or your animation will not look desirable. So else state equal to 1. So if it has decreased below -10, that means it now needs to go to the right side. That means we'll keep the state variable 1. We'll make it positive, and now we'll break. So that just results in a back and forth bouncing of the object. Let's see if this is working. So there we go, we have our animation here, right and then left, and then it'll go right again. Now if you want to increase the speed, do not change the frame rate. Keep the frame rate constant, just change the rate at which the variable is being updated. So that will just increase the speed of the object. It is going twice the speed now. So that is how the simple animation works. So hope you've enjoyed this video tutorial. If it was helpful, please like and subscribe, and thanks for watching the video. and I'll see you next time.